Geometry lesson, angle, angle side, triangle congruence. All right, guys, this is Are You Ready exercise. Let's do it as a warm-up, guys, okay? Why don't you try these problems and see if you are ready, okay? Please pause the video. All right, guys, here it is. So answer to the first one is 5. 2 is a square root of 29. Okay, you could clearly see the work over here, guys, okay? The distance formula, obviously, is the same thing as Pythagorean theorem. So you could just use the Pythagorean theorem, or you could use the formula over here. But I personally think it's more natural to be using this. Okay. And this is true by side, side, side. And using the, you could find these values using the Pythagorean theorem. Sounds good? All right. Let's begin. So we have a note here. Please copy down the missing pieces. Angle, angle, side, congruence theorem. If two angles and non-included side of one triangle are congruent to the corresponding angles and non-included sides of another triangle, then triangles are congruent. Prior to this, we had a triangle that had angle side angle. But if you sort of think about this, right? So we had something like this before, like angle, side, angle, angle, side, angle. But if you sort of think about it, right? If the two of the angles are the same, shouldn't the third angle be the same? Have to be the same, right? Because they have to add up to 180. So it makes sense over here, like this. So if that's the case, then angle, angle, side is essentially the same thing as angle, side, angle, isn't it? Yeah. So basically, that's what we're going to prove right now. Okay. So like before, in this case, the given information is that if you got two triangles this way, ABC, and let's say XYZ, you got angle followed by angle, the two sides are the same, then triangle ABC is congruent to triangle XYZ. Okay. All right, guys, here's a proof of the angle angle side using what we know before. Okay. We know that the A and D are the same. So we know these two are the same. And we know that the C and F are congruent. And we know that BC and EF are the congruent, this and this right there. Okay. Now we're going to prove this. Just remember, the guys, we could always use the stuff from the previous, right? We could always use we're allowed to use previous theorem as one of our tools, previous theorems. Obviously, if we've been using those theorems, it's already been proven, right? So the first thing I would do is actually copy down all the theorems over here, right? All the given information. And we would know that the angle A, B, and a C add up to 180. DEF adds up to 180, isn't it? And then we could set it equal to each other. Now, do me a favor. Me having given you that much more information, can you do this? Write this out on your own. If you can, pause the video. Otherwise, I'll just move ahead with what I already wrote down. So here it goes. So what I did was I wrote down this information. I call that given. And I said angle ABC, A, B, and a C adds up to 180, and DEF adds up to 180 right there, guys. Because the sum of the interior angles of the triangle is 180 degrees. Because they're both equal to 180, I set them equal to each other. We call that transitive property. If you want to call it substitution, I'm okay with that as well. So it's transitive property of equality. Okay. Now, once you do this, I'm going to substitute because we know that the A and D are equal and C and F are equal. So I replaced the D and F for A and C. That's why substitution property. I forgot to write the word property right there. And then we subtract A from both sides, C from both sides. We're left with B and E are equal to each other. So we call that subtraction property of equation or equality. And hold on a second. We have the information that C and F are equal to each other right here. And we just found out the B and E are equal to each other. And we know the length between the two are also congruent right there. So we got angle, side, angle. So by angle, side, angle congruence theorem, congruent triangle theorem, there you go, right? That angle, triangle ABC and triangle DEF must be congruent, right? So from now on, what you could say is that if you have angle, side, angle, that's pretty much the same thing as angle, angle, side, okay? Because of the third angle theorem that we just did. This part right here, when the two of the angles are the same, then the third angle must be the same. Some books, they call that a third angle theorem, okay? All right, guys. Let's move on to some exercises over here, all right? I've got example 6.22. That's actually the textbook homework problem, the even questions, which I didn't assign. And then we got 6.28 and then 6.18. 6.2.18. Do me a huge favor, guys. Try to see if you could do this on your own first. If you could do it on your own first, it shows that you're in great shape. Okay, if you need a little bit of help, just wait a second. All right, the second is up. So in this particular case, we need to decide whether we have enough information. All right, we know that this and this is the same. We know that this and this is the same, right? So we got 2 that goes to 1 tick mark and with the same side, 2 to a single tick mark for the angle, and this is the same. So what we can do is that 1, 2, 3. See, 1 tick mark, 1 arc, 2 arc, no arc, 1 arc, 2 arc, no arc. So I labeled it 1, 2, 3, and then 1, 2, 3. So that's ABC is congruent to FED. So you need to be very careful how you set the correspondence, right? They're congruent by angle, angle, side, triangle theorem. And for the next one, we don't have enough information. Well, not yet anyways, right? So we know that these two angles are the same because they're both 90 degrees, and we know this is the same, and we're done. That was it. However, right, these two will be the same if the AC and EF were the same. AC and the EF, then that would become what? Side, angle, side, wouldn't it? Or if we had this right here, right? If B and D were the same, we'd have angle, side, angle. Or if we had E and A were the same, the angles, we'd have angle, angle, side, right? So if we don't have enough information, just knowing what we need to make it congruent is a good exercise to do. And the last question over here, guys. So I marked all these up right here, guys, right? Let me just cut that out for a second, right? And then we had this in a coordinate plane. We know that the AE right here, A and E are the same. We should mark that up. C and F are the same. We should mark that up. Wait a minute. If these two are the same, remember that angle, angle. Look at the context, guys. We're learning angle, angle, side. So angle, angle, side. Is there a way to show that the BC and DF is the same? Yeah, we can. Count this. 2, 4, 6, 8. The length is 8. But each tick mark 1, 2, 3, 4, right? Times 2 is 8. 1, 2, 3, 4 is 8. They're the same length. So when it's on a horizontal or vertical, like this, horizontal or vertical, you don't have to do this. You could just count, okay? So now if you're looking for, let's say, length AB and DX, you could just count. But if you look at this over here, guys, right? There are 2 ways we could have done this. The first one, that's the better choice, obviously. The second choice was AB versus DE. And because, let's zoom in, that's 2 and a 2, and a 2 and a 2 here and here, we could figure out the length fairly quickly using the distance formula, right? So either way, these two trunks are congruent by angle, side. Okay. The pink, the magenta, was the easier of the two. All right, guys? Okay. So now comes your turn. Here you go, guys. All right. So we'll go over this in class. So please work it out. Okay. But here are the answers. If you have questions, we'll go over in class, but I won't explain it now. Pause the video. Unpause when you're done. Here you go. And here you go. And there you go. Okie dokie, guys. All right, guys. Thanks for paying attention. I'll see you in class tomorrow, okay? Bye-bye.